Hi and welcome to Maths class. Today we're going to talk about independent and dependent events in probability. So two events are independent if the outcome of one event does not depend on the outcome of the other. And a simple example is if I flip a coin twice. I flip it the first time, I get heads. Does that make it more or less likely that I get heads the second time? The answer is no. It will not change the likelihood of my getting heads the second time. Those two events are independent. So here's another example, rolling a 6 and then flipping tails. It doesn't matter whether I get a 6 or not the first time. It's not going to change the probability, which will be 1/2 of flipping tails with my coin. Now, sampling with replacement is also independent. So if I draw, let's say, a coloured marble from a bag, note the colour and put it back, that's going to be independent because I put the marble back. I haven't changed what's in the bag. Now, two events are dependent if the probability of one depends on the outcome of the other. And here's an example I've just made up. If event A is having warm weather and event B is I go for a walk in the park, the probability of B is going to change depending on whether or not A happens. Now in the summer, the likelihood of A is very high, and in the winter, the likelihood of A is lower. So that also changes. But if we can pick for one given day what the probability of warm weather is, and if I know how those probabilities change depending on the weather, then I can calculate all the relevant probabilities. Another example of dependent probability is sampling without replacement. So I draw a coloured marble out of a bag, I observe the colour, I keep it, and then I take another one. What's in the bag has changed because I've kept one marble out. And depending on what colour I've got in my hand is going to change the probability of the next one. So sampling without replacement is an example of dependent events. Now, if I've got independent events, then I can use this rule. The probability of A intersecting B, that is the probability of A and B happening, is the probability of A times the probability of B. For example, when I said before that I've got rolling a 6, let's make that probability A. So rolling a 6, my probability is 1/6, and my other one was flipping tails. The probability of that happening is 1/2. So the probability of rolling a 6 and then flipping tails is 1/6 times 1/2, which is 1/12. So when my events are independent, I can use this rule. But when my events are dependent, I need to draw a tree diagram. It's not a simple thing to work out different probabilities. So I'm going to do this example. The probability that I take a walk in the park today is 4/5 if it's warm and 1/3 if it's cold. So notice that 4/5 and 1/3 have nothing to do with each other, okay? On a warm day, 4/5 probability that I'll take a walk. That means on a warm day, there's a 1/5 probability that I won't take a walk. If it's a cold day, the probability I'll take a walk is only 1/3. That means there's a 2/3 probability that I won't take a walk on a cold day. Now, the probability that it's a warm day today is 5/6. It must be summer. This isn't true. It's not summer. I wish it was. All right, so we need to calculate the probability that I walk in the park today. So this is what we're going to do. I'm going to make a tree diagram, and I've already started it. We're starting with the thing which we have no control over, which is the weather. Either it's going to be warm or it's going to be cold. But I know what the probability of those are. Probability it's warm today is 5/6. That means probability it's cold today must be 1/6. Okay? Now, if it's warm, what's the probability that I take a walk? It's here in my question. If it's warm, the probability I take a walk is 4/5, which means the probability I don't take a walk, which I've just written as walk dash, the complement of taking a walk, is 1/5. Okay, those two add up to 1. Whenever I'm doing one set of branches, those two add up to 1, those two add up to 1. When it's cold, I've got a probability of only 1/3 that I will take a walk, which means the probability I don't take a walk is going to be 2/3. Those two have to add up to 1. So be really careful when you're filling out your probability tree that you notice that these two numbers have nothing to do with each other, right? If it's warm, then this is my walk probability. If it's cold, then this is my walk probability. Okay. But the question is, calculate the probability that I walk in the park today. Now, there are actually 2 outcomes here where I walk in the park. So I need to calculate them separately and then add them together. So the probability that it's warm and then I walk is going to be 5/6 times 4/5, which gives me 20 over 30, which is 2/3. Now the probability that it's cold and then I walk is going to be 1/6 times 1/3, which is going to be 1 over 18. Now, the probability, therefore, that I walk is the sum of those. It's going to be 2/3 plus 1 on 18. I can rewrite my 2/3 as 12 on 18 plus 1 on 18. So it is 13 on 18. Okay, so just to recap, dependent versus independent. Independent events don't depend on each other. They're things like flipping coins and rolling dice where one outcome does not change the probability of the next outcome. Dependent events is when one outcome changes the probability of the other outcome. If it rains, I'm more likely to carry an umbrella than if it doesn't rain. Those are dependent. If I've got independent events, I can multiply these together to calculate the probability of 2 things happening. But if they're dependent, I really need to draw my tree diagram and do it more carefully. All right.